Hi there, my name is Victor. Today I will show you our work, Causal RAG. Large language models and RAG have fundamentally changed how we access and interact with information. Over the past few years, the RAG community has invested heavily in improving answer accuracy. A wide range of strategies have emerged, such as graph RAG, multi-agent RAG, advanced retrieval pipelines, and re-ranking techniques, all designed to push the boundaries of reliability and precision. RAG somehow solves those straightforward what questions, surface-level queries that focus on retrieving and summarizing facts. However, RAG often struggle to answer complex why questions, like what are the drivers behind Salesforce's net margin increase? They also struggle with non-obvious what questions. Effective answers must be supported by causal facts to provide meaningful context. Sometimes it even makes basic calculations wrong. About a decade ago, Judea Pearl, Turing Award laureate and widely regarded as the father of causal inference, wrote in the Book of Why that causal questions can never be answered from data alone. I can't agree more with Prof. Pearl. Therefore, in order to solve complex queries and answer why and non-obvious what questions, we build a system incorporating causal structures into reasoning and retrieval process. We call the system Causal RAG. In baseline RAG, embedding similarity and a fixed top K retrieval are weak logic for selecting the right facts. These strategies cannot guarantee sufficient information to answer why or non-obvious what questions. Our approach, therefore, places factual correctness at the foundation, leveraging causal structures to ensure that answers are both accurate and supported by original content. Here, we use a causal RAG agent applied to 10K reports as an example. It follows 4 steps. First, building an approximation. We abstract 10K reports into an approximation that captures their core business logic and key data with causal graphs, sentiment relationships, and selected financial figures. Secondly, fact extraction via code generation. When a user submits a query, the agent leverages this approximation to generate executable code. The code is run in a local environment to extract and distill the precise business facts needed for analysis. Thirdly, insight generation. The distilled facts are then passed to a foundation model which produces higher-level insights. Finally, evidence retrieval and answer the question. Finally, the agent strengthens its insights by performing vector searches against content stored in the BigQuery dataset to surface supporting materials and then answer the user question, combined insights with supporting materials. The most critical concept in causal RAG is approximation. To answer why and other non-obvious questions, foundation models must first capture the underlying causal effects before generating tokens. This is where approximation, enriched with causal graphs, sentiment relationships among variables, and key financial data, becomes essential. Since 10K reports are static records of past business activities, their approximations can be pre-built as a one-time effort, avoiding unnecessary overhead from dynamic generation. For this hackathon, the approximation is organized into 2 sets, income statement and balance sheet. Within the income statement, for example, the causal graph encodes relationships among variables such as net income, revenues, and costs, grounded in deterministic accounting principles. Sentiments among these variables are expressed through accounting formulas, ensuring that the agent reasons over financial logic in a manner that is both consistent and causally sound, rather than relying on surface-level text. Income statement data is also collected in a CSV file. The entire causal modeling stack is built on BigQuery, with its generative AI capabilities playing a central role. In the preparation phase, the agent leverages ML-generate text to extract key elements from user queries, such as company names, and to classify intent, but the true value emerges in downstream stages. For fact extraction, instead of relying on direct model reasoning over complex financial data, the agent uses BigQuery's generative AI to produce code that programmatically filters and extracts the necessary information from pre-built approximations. This design not only takes advantage of foundation models' stronger training and coding tasks, but also ensures cost efficiency by enabling deployment with lighter models like Gemini 2.5 Flash while maintaining accuracy and scalability for enterprise use. By avoiding direct processing of large datasets, the system achieves both speed and reliability, regenerating complete extraction applications when needed rather than iterating with heavier React-style frameworks. In parallel, vector search SQL generation further demonstrates BigQuery's strength. Semantic search retrieves the most relevant evidence chunks using cosine similarity, while dynamically generated SQL, augmented with parameters such as company name and report year extracted from the query, ensures precise grounding of answers. Together, these capabilities position BigQuery's generative AI not just as a utility for text processing, but as the backbone for a scalable, efficient, and evidence-driven causal RAG pipeline. To evaluate the agent's ability to handle complex queries, we created a focus test set spanning two categories: basic fact and calculation questions, which test performance on straightforward what queries, and drivers and trend analysis questions, which test the ability to tackle non-obvious what and why queries requiring deeper reasoning. This balanced design measures both surface-level accuracy and causal understanding. We then compared three approaches: a baseline RAG supported by BigQuery's vector search, Gemini 2.5 Pro with ThinkOn enabled, and our Causal RAG agent. The results show that Causal RAG not only significantly outperforms the baseline RAG on both simple and complex queries, but also delivers greater stability and reliability than using Gemini 2.5 Pro alone. Let's see a few evaluation samples. Okay, let's run Causal RAG on a why question, identifying the drivers behind Salesforce's increased profit margin in FY25. The process begins with Causal RAG selecting the corresponding approximation through a series of structured steps. Next, Causal RAG generates code to extract the relevant facts, producing a structured list of the key information required for further investigation. Then, insights are distilled from the extracted facts, and based on these insights, Causal RAG retrieves supporting evidence from the document chunks stored in the vector store. Finally, both the insights and supporting evidence are passed to the foundation model, which synthesizes them into the final answer. On the left is the answer from the baseline RAG, and on the right is the response from Causal RAG. Unlike the baseline, which lacked depth and explanatory power, Causal RAG delivered a structured, root-cause-oriented analysis. For example, while Salesforce's top-line growth from FY24 to FY25 was solid at 8.7% year-over-year, the more critical driver was on the bottom line. COGS grew only 1.7% and operating expenses 2.94%, significantly amplifying net margin performance. Causal RAG surfaced and explained this causal dynamic, whereas the baseline RAG failed to offer details as in-depth as possible. Let's take another trend question that requires analyzing data points across multiple PDFs. To what extent is Salesforce exposed to material goodwill impairment risks, and what is the potential impact? Causal RAG follows the same process, selecting the appropriate approximation, generating facts through code, distilling insights from those facts, and then retrieving supporting evidence from the vector store. Causal RAG showed its strength by surfacing Salesforce's goodwill risk, and it even quantified the impact. Causal RAG also outperformed baseline RAG on trend analysis questions. Baseline RAG fails because it cannot assemble sufficient relevant material to construct an answer. Causal RAG, by contrast, can leverage approximations and structured data to reason over time series patterns and provide a well-founded response. We found that while Gemini 2.5 Pro performs well in most cases, it struggles with large batches of PDFs, for example, failing on queries across multiple annual reports. Causal RAG, by contrast, matches its reasoning performance while delivering far greater stability, making it more reliable for enterprise-scale use. Causal RAG has huge business potential. At the enterprise level, Causal RAG helps finance teams reclaim 20–30% of their time, saving $10 to $15 million a year for a single Fortune 500 company. At the industry scale, global firms spend $40 billion annually on analysis. Even a small 5% efficiency gain translates into a $2 billion opportunity. And strategically, with 90% plus accuracy versus today's 65%, Causal RAG isn't just faster, it's trusted for regulatory reporting, risk analysis, and investor relations. In a nutshell, Causal RAG enhances traditional RAG by combining approximations with causal graphs, sentiment links, and structured data to deliver reliable fact extraction and deeper reasoning. It consistently outperforms baseline RAG, proves more stable than Gemini 2.5 Pro in multi-document tasks, and bridges scalability with reasoning quality, showing how enterprises can leverage BigQuery's generative AI and vector search for cost-efficient, fact-grounded, and causally aware analysis. Thank you for watching.